Back in 2023, building AI meant writing imperative Python scripts to wrap API calls. We chained them together and hoped for the best. This approach functioned as simple robotic process automation. Developers scripted the entire workflow manually, using a chatbot as a formatting layer at the end. These systems were fragile. They frequently hit context window limits, and a single error anywhere in the chain would crash the entire application. This flowchart shows a traditional retrieval-augmented generation, or RAG, pipeline. A user query goes to a database, pulls exactly 3 fixed results, and feeds them into the language model. Because the developer hard-coded the workflow, the system cannot adapt to complex or ambiguous problems. The era of simple prompt wrapping has reached its limit. Scaling AI now requires an engineering platform where the model, not the developer, determines the workflow. To build a reliable system, you need a model-agnostic architecture. This lets you swap reasoning engines between OpenAI models, or Anthropic Claude, or Google Gemini, without rewriting the agent's core logic. The system runs on a 3-stage agent loop. First, call model, where the agent analyzes its state. Second, it selects an action, evaluating tools to advance the task. Finally, the tool executes, feeding results back to reasoning until the goal is resolved. By managing this execution loop, the language model becomes an active, dynamic reasoning engine orchestrating its own state. In this architecture, tools are not hard-coded if-then statements. Instead, they are a toolkit described via structured schemas, giving the agent the ability to choose its capabilities. For example, if an agent needs to answer a complex historical question, it can choose to use a Wikipedia tool to research the life of Alan Turing. The tool executes, providing the factual context needed to generate an accurate research note. This network visualization illustrates agentic RAG. Here, the language model probes multiple different database nodes, analyzes the quality of each return, and decides for itself if it needs to query again to find better information. This shift gives the model agency over its own memory. Data retrieval is no longer a fixed pipeline. It is a dynamic, investigative process driven by the model's reasoning. Sophisticated agents often run multi-hour research tasks. If the system crashes halfway through, you risk losing all progress and wasting expensive compute time. LangGraph addresses this risk by providing a framework for durable execution. It ensures that complex multi-step workflows can survive interruptions. Agents move through complex steps like A, B, and C. If a crash hits node B, a standard script loses everything. But LangGraph saves the exact state at every step using checkpoints. Upon restart, it resumes execution directly from the point of failure. This capability eliminates the cost of rerunning successful steps, making AI workflows durable enough for production software. Production agents also require secure environments. Deep agents allow you to run an agent's code in isolated remote sandboxes with role-based access control, protecting your internal networks from unauthorized access. To manage these systems, Langsmith provides an observability layer. Teams can trace every tool call, test agent behavior, and replay production failures to improve reliability. The role of the developer is changing. Success now depends on orchestrating reliable, state-driven autonomous systems rather than finding the right prompting hacks. You can find the documentation and reference architectures for these systems at LangChain Academy and the community forums. Move beyond simple prompt wrappers. Build your architecture on these engineering principles and start shipping true agents today.